Okay, so first section we're going to look at this week is the factor theorem, okay, section 3.3. And just a couple reminders about, we're going to look at roots and zeros and different things that mean the same thing. So just remember, if something is a root or it's a zero, that means it's a number that you plug into an equation and get 0 as an answer. All right, so if I had something like, let's do this, 2x plus 6 equals 0, and I said find the roots. Well, the root is -3. That's the number that if you plug it in for x, you get 0 for y. It's also where the graph would cross the x-axis. Okay, I didn't write that one, but I think we might have talked about that one before. If you drew it, the graph would cross the x-axis at -3. Right, and this statement, this word IFF, that's an abbreviation for if and only if. Okay, so from geometry, remember, if and only if means you can read a statement forward and backwards, and it's true both ways. So if you want to write out this last statement the long way, you could say that if a is a root, then f of a equals 0, which means if a number is a root, plugging it into an equation gives you 0. Or the other way you can read it is if you plug a number into an equation and get a 0, then it is a root. So you can read it, if it's a root, and you plug it in and get 0. If you plug it in and get 0, then it's a root. So you can read it each way. So what we're going to do is we're going to look at using long division. Long division, not as easy as synthetic division, but the advantage of it is it works all the time. Synthetic division is faster, but it only works some of the time. Right? In general, though, once we learn long division and synthetic division, if a problem doesn't say which way to solve it, I don't care which type of division you do. All right. So when we do long division with polynomials, I think it's easier if we just look at long division with regular numbers first and kind of see what we're going to do. So let's say that I wanted you to factor the number 12. Okay. To factor the number 12, that means to write it as something times something gives you 12. Well, I'm going to tell you that 3 is a factor. Okay, so I'm giving you one of the factors of 12. I want you to find the other one. Well, it's obviously 4. Right? We know 3 times 4 is 12. But if it was something a little more complicated, like a polynomial, you might not be able to just figure out the other factor in your head. All right? So that's where if we do what I'm about to show you, we can figure it out. So if 3 is a factor, that means 3 times something gives you 12. How would you get the something? We know it's 4, but what could you do on both sides? Yeah.
Divide by 3.
Divide by 3. So if you take and divide each side by 3, 12 divided by 3 gives you 4. If you check it, 3 times 4 is 12. There you go. You just factored the number 12. And the whole key was dividing. Okay. We took what we had, we divided by something that we knew was a factor, and we got the other factor. And the important thing is, if you notice, when you divided 12 by 3, you didn't get any remainder. That proves that 3 is a factor of 12. Okay? Whenever you divide by something, if you don't get a remainder, then that means it's a factor. So if I check 6, 12 divided by 6 goes in twice with a remainder of 0. Then 6 is also a factor of 12. If I check 8, 8 goes into 12 once with a remainder of 4. 8's not a factor of 12, okay, because there's a remainder. All right, so that's going to be a big thing. When we want to check if something is a factor, we're going to do division and check for a remainder of 0. That's how you check for factors. And we're going to do the same thing with polynomials. So that's what I'm going to show you next. Questions on the concept? That's the idea behind what we're doing. Okay. That I just said to you, if you want to write it down, what I said again, you can, but if you divide two numbers and get a remainder of 0, then what you divided by is a factor. Okay, just said that. So the reason why we want to factor polynomials, okay, so it makes it easier to find the roots. Let's say I gave you a problem like this. X squared plus 7x plus 6. And I said, quickly, tell me the two numbers you can plug in for x that give you 0. Most people aren't going to get that super quick. But if I wrote it this way, and I said, tell me what number you could plug in for x to get 0 in the first parenthesis, it would be -1. What number could you plug in for x in the second parenthesis? -6. The reason it's so much easier with the parentheses is because it's factored. Okay, so that's why we factor. Makes it easy to find the roots. So we're going to look at the same process we just did, like that 12 divided by 3, all that stuff, except I'm going to show you how to do it now with a polynomial. So it could be something like this. Let's say I said to you, okay, I want you to factor that, and you were stuck. You couldn't figure out how to factor it. Well, if you divide by x plus 1, you can figure out what the question mark is. Okay? That's not too bad. You should be able to factor that without division. But if you couldn't, you could use division to figure it out. All right, so I'm going to give you the steps for long division. I think it's easier if I show you an example as we go through the steps. So there's 4 steps. Depending on how big you write, I think you could fit all 4 on 4 lines. So what I would do is leave yourself like 4 lines, or actually 5 lines. The last step is to repeat until we're done. So leave yourself 5 lines, and then below that you could put the example that we're going to do. Okay, so they're just having me practice dividing this. They're not having me do anything else. Just divide x minus 3 into x cubed minus 8x plus 3 and see what we get. Okay. So the first thing we have to look at is what's under the symbol. Okay, what's under the dividend symbol? Right there. And if we look at that and we're missing any terms, we have to fill in 0 for those terms. What do I mean by missing? Well, we've got x cubed. Where's the x squared? It's not there. Right, so what we're going to do is we're going to fill in a 0 for the x squared term. So I'm going to rewrite it. Okay, so we got x cubed. What number is in front of x cubed, even though it's not there? Yeah, that's a 1. Okay. There's no x squareds. And if you're like, well, why do we even bother writing it if it's not even there? Because we need to have like terms in columns. And if we don't have a column for the terms that have an exponent of 2, things won't line up right. So there's our cubed, squared, linear, and constant. So that's step 1. Bless you. Okay, step 2 is to divide the first term of the divisor. That's the thing on the outside, and I just circled the first term. Divide the first term of the divisor into the first term of the dividend. That's the thing on the inside. Okay, so what we're basically going to do, just kind of show you up here, is that x cubed divided by x. Okay. What do you get when you divide x cubed by x to the first? Yep, x squared. So we're going to put x squared. I don't care where you put it up above the line. It's just stuff below the line you have to put in columns, and I'm going to show you that right now. Okay. So now we did step 2. Step 1, step 2. Questions on steps 1 or 2? Okay, step 3. Take the answer that we just got in step 2. And we're going to multiply it back out to each term in the divisor. Okay, so we're going to kind of go like this. So we're going to multiply it back out. And when we do that, we have to put like terms in the same column. Okay, so let's watch what happens here. X squared times x gives me x cubed. X squared times -3 is -3x squared. Make sure you put it in the squared column. And that's step 3. Any questions on that? So we divide, we multiply. What's the next thing you do in long division at this point? Like if it was just regular numbers. Before we bring down, there's one thing we have to do before we go to the next one and bring it down. Subtract, yeah, we have to subtract your columns, right? That's what you always do in long division. Divide, multiply, subtract, bring down. So just be careful that when you subtract, you realize you're not just subtracting the first thing, you're subtracting everything. So that's why I put it in parentheses. So if you look at what happens, x cubed minus x cubed, what happens there? It cancels. That should happen every time. If it doesn't, something's wrong with what you did in step 2. So now we're subtracting our columns. Okay, I subtracted the first column. Don't forget the second one. 0x squared minus 3x squared. What's 0x squared minus -3x squared? 3x squared. Yep. And if you look at what happened, look at the exponent we started with on the inside. It was a 3. Look at the exponent we have now. It's a 2. It went down. That's what's going to happen. You're done when that exponent is smaller than that exponent. Or you get a remainder at 0, and then you're also done. But that's the last step. It tells you when to finish, how you know when you're done. Okay, so once we subtract our columns, bring down the next term, which I should probably do that right now, minus 8x. And I'm going to keep going until the degree of the number on the inside is smaller than the degree of the number on the outside. Because once the one on the inside is smaller, then the one on the outside can't go into it. You can't. It doesn't work. Something bigger doesn't go into something smaller. The other way around. Okay. Or we might end up with no remainder. Some problems we will get a no remainder. Some we will, some we won't. Okay. And now, so we just keep repeating that process. Okay. From steps 2 through 5. You've already done step 1. You never have to go back to step 1. Just steps 2 through 5. Okay. So now divide the first term here into the first term there. So what's, if you want to think of what you're doing off to the side, you're doing that. What's 3x squared divided by x? 3x.
Shouldn't that be a -3x?
No, because it's minus a minus. Yeah, you gotta be careful with that. All right, multiply our answer back out. 3x times 3x is 3x squared. What about 3x times -3? Minus 9x, we got to make sure we put that in the x column. And now subtract. Again, I would put parentheses just to remind yourself you're subtracting both of them. 3x squared minus 3x squared. Again, as long as you've done it right, that part should always cancel. How about -8x minus -9x? Just x. It's really -8 plus 9. So you've got an x, bring down your next term. Now look at the exponent. Exponent on x is a 1. Exponent on the outside was a 1. So now it's not less yet, but it will be. So this is the last time through, and then we're done. All right. So divide x into x. What's x divided by x? 1. If the directions said find the quotient, you're done. That's the quotient. Okay. If they want the remainder, we got to keep going. Okay. So multiply the 1 back out. 1 times x. 1 times -3. And this is where sometimes people look real quick and they're like, oh, 0, remainder, I'm good. Be careful, because you're subtracting. What's the remainder there? 6. It's 3 minus -3. So I got a remainder of 6. That means x minus 3 did not divide into it evenly, which means x minus 3 is not a 1. It's not a factor. So if you were trying to factor x cubed minus 8x, x minus 3 is not the way to do it. Okay. They didn't ask if it was a factor, they just said divide it. Okay. Couple ways you can write your answer. You can write quotient, x squared plus 3x plus 1, and remainder is 6. Or you can write your answer the same way you would do it with numbers if it was long division. Let's look at 12 divided by 7. How many times does 7 go into 12? Once, with a remainder of 5. So that's kind of like what we just did. Quotient, remainder. Or you can write your answer this way. Quotient plus remainder over your denominator. So if you wrote your answer that way, that's 1 and 5/7. Or if you write it as a mixed number, 1 and 5/7. 12 divided by 7. Okay. You can do exactly the same thing with a polynomial. Quotient, x squared plus 3x plus 1, plus remainder, which is 6, over your original denominator. What did we divide by? X minus 3. Both of those answers are correct. It's just a matter, do they want you to write it like that, or do they want you to write it like that? So put a box around that one and around that one. The second one is nice because you can check it on the calculator. You can check that you actually did it right. Okay. And I'll show you how you can check your answer. Type your answer in. X squared plus 3x plus 3x plus 1 plus, and now we just have to use parentheses around this last part. 6 divided by x minus 3. Pretty sure that's how you got to type it. All right. So we've got, oops, forgot a parenthesis. All right, so we just typed in our answer. Now, if you type in the original problem, when we graph it, our answer and the original problem should look exactly the same if we did it correct. So let's type in the original problem. The original problem was, let's see, x cubed minus 8x. Don't worry about 0x squared. The calculator doesn't care about that. Plus 3. And we divided by x minus 3. So y2 was the original problem. y1 is what I think we should get for an answer. So let's graph them. And as long as I typed in all my parentheses right, we should be okay. So there's our answer. Doesn't matter what it looks like, it looks like that. And what's in red is going to be the original problem. It's tracing over it exactly. So that means that our answer is correct. Okay. If you write your answer as Q and R separate, you can't really check that on a calculator. You've got to type it in like that to check it. That's long division. Any questions on that one? Okay. Let's try one more with long division, and then we'll look at something else. Okay, this one, what did they already do for you? This won't normally be done for you on the test. You'll have to do this yourself. They put the zeros in on this one. Okay, so step 1, put the zeros in, already done. So we can go right to step 2. So step 2. Doesn't matter if there's 3 terms on the outside, 2 terms. Take the first term on the outside, divide it into the first term on the inside. It's off to the side. That's what you're doing. 2x to the 4th divided by 2x squared. Okay, and what does that give me? X squared. Okay. I'll know if I did it right because when I multiply it back out, if the first term doesn't cancel, something's wrong. Okay. So x squared times 2x squared. X squared times x gives me x cubed, because remember there's a 1 if you want to put that in. And then x squared times 1 is x squared. And what am I going to do with all 3 of those columns? Yep.
Multiply by negative.
Yeah, right. You're going to subtract them, which is basically like changing the sign of each term. You could also think of it that way. I usually just write it like that. If you actually want to take the step and distribute the negative out, you can do it. It's up to you. 2x to the 4th minus 2x to the 4th. That's good. Negative x cubed minus positive x cubed. What's that? Yep.
Negative 2x cubed.
Yep, negative 2x cubed. Would have been nice if it canceled, but it didn't. And then 0x squared minus positive x squared. Okay, so we get minus x squared. And now, even though it's a 0, bring down your next term. It's just going to help you remember that whatever you get below it, it's going to be 0 minus whatever number you get. Okay, so now we have to divide negative 2x cubed by 2x squared. What do we get there? Yep, negative x. Multiply it back out. Negative 2x cubed. Now this is good. Watch what's going to happen here. Negative x times x is negative x squared. Okay, so we're going to get a couple things that cancel, which means this problem's going to be done right now. Right? If that, you'll see in 1 second. And then negative x times 1 is negative x. Bless you.
Thank you.
And as Harris said, change the sign or subtract them, however you want to think of it. Okay. What's negative 2x cubed minus negative 2x cubed?
Positive 2x cubed.
It cancels. It's gone. That's 0. What's negative 2x cubed plus 2x cubed? How about negative x squared minus negative x squared? That cancels too. Whenever that happens, that's always nice. And then 0x minus negative x. 1x, or just x. And don't forget the negative 2. Bring that down. That's your remainder. Okay, so your quotient is x squared minus x. And your remainder is x minus 2. If you're wondering, well, how come you can't go any further? Well, the exponent here is a 2. What's the exponent on x? It's a 1. 1 is smaller than 2. Okay? In our directions, once the degree of the remainder, which is what's on the inside, is smaller than what's on the outside, you can't go anymore. That's why we're done. 1 is smaller than 2. Okay? So any questions on that? Let's see, so do we need... Okay, so let's look at this real quick. It kind of looks confusing when you look at it at first. But if I show you how this works with just numbers and take all the letters out of it, I think it'll make sense. So what it's saying here is if you divide two polynomials, when you divide them, you're going to get a quotient and you're going to get a remainder that always make this equation true. F of x will always equal h of x times the quotient plus your remainder. And all that really is that's how you check your answer in elementary school when you do long division. Let's pretend that in our example, f of x was 13, and we wanted to divide it by 4. F of x is 13, so I'm basically doing this. I'm doing long division, 4 divided into 13. If I divide 13 by 4, how many times does 4 go into 13? 3. That's the quotient. And what's the remainder? 1. So fill in those 4 numbers in those 4 spots and watch what happens. Your numerator, okay, f of x, what you were dividing into, equals your denominator, you divided by 4, times your quotient, bless you. Your quotient was 3, and your remainder was 1. Is that true? Does 13 equal 4 times 3 plus 1? Yeah. So basically, that's how you check your answer when you do long division in elementary school, and you could check your answer exactly the same way with the stuff we're doing today. I think it's even easier to check your answer with the graphing calculator, but I'm just showing you another way you could check your answer. That's all that is. Okay. Yeah, come on. All right, so what I'm going to give you is what's called the remainder theorem, and it's a quick way to find the remainder to any problem without actually doing any division out. All right. So, like I said, sometimes all you want to know is the remainder. And why would you want to know the remainder? Because if the remainder comes out to 0, that means something very important. We already said it. It means what you divided by is a factor. So I'm going to show you a quick way to check the remainder. Unfortunately, this theorem only works if you divide by something simple. All right? You can have anything you want in the top, but in the bottom, you have to divide by x minus a number. Okay? It can't be x squared. It can't be anything fancier than that. It has to be x minus a number. So if we go back to the first one, this theorem I'm about to show you, it would have worked on this one. It's x minus a number. It would not work on the second one. This is too complicated to use the theorem I'm about to show you. So as long as you divide by x minus a number, if you want to find the remainder, all you have to do is take that number, whatever it is, and plug it into the formula in the top. So you don't have to do any division at all. All you have to do is evaluate. Take a number and plug it into something and see what you get. What number do you plug in? The one after the minus sign. Where do you plug it in? The top. You plug it into whatever's in the top. And I'm calling the top f of x. All right, so if you want me to actually, I can write that out. Take that number, plug it into whatever formula is in the top. And remember, if the top has multiple x's, you got to plug it in everywhere. So plug it in for all the x's. Okay. So let's find the remainder when we divide x cubed minus 2x plus x minus 5 by x minus 3. Okay, that's the first one I'm going to do. And then I'm going to do another one dividing by x plus 1. So we're going to do two problems. So the first one we're going to do is this divided by that. Now, do you have to use the remainder theorem? No. You could go through and do long division. Get the remainder just like we did. But this is going to be way faster. Okay, it's way faster. All right, so let's do remainder of f of x divided by h of x. So let's do that one first. All right. So is h of x of the form we want it to be? Is it x minus a number? Yeah. Yes, it is. So all you want to look at is this. What's after the minus sign? Okay. What's after the minus sign in h of x? 3. That's the number we want to work with. So we're going to take 3 and we're going to plug it into the formula in the top. Well, the formula in the top, I called that function f. So basically just plug 3 into f and do it out. And that's your remainder. So we're going to get 3 cubed minus 2 times 3 squared plus 3 minus 5. And it's small enough, I think we can do it without a calculator. What's 3 to the third power? 27 minus 3 to the second power is 9 times 2, 18. So now we just need to finish that off, which is way faster than doing long division. 27 minus 18 gives me 9. So 9. And 9 plus 3 gives me 12, and 12 take away 5. 7. There's your remainder, without doing any long division. So what does that mean about h of x? Is it a factor of f of x, or no? No, it's not. So if you were trying to factor f of x, x minus 3 is not the way to do it. Yeah.
So you wouldn't carry the negative sign with the 3?
No, it's just the number, just what I circled, just the number after the minus sign. Whatever is after the minus.
Can it be x plus a number? That's
what we're going to look at right now. Yes, it can. We just have to be careful with our sign. So now I want to do the remainder of f of x divided by, what did I call the other one? G of x. Now, are we dividing by x minus a number? The way it's written. Does g of x say x minus a number? No, it doesn't say it, but we could think of it that way. How can you think of it as x minus a number? Yeah. Right, x minus negative 1. And now, that's the number after the minus sign. So the answer is yes, you can do it with x plus a number. You just have to think of it as x minus, and then whatever comes after that, that's what you plug into the top. So now, we're not going to plug 3 in. That's what was after the minus sign before. Now it's negative 1. Okay, that's what we're plugging in. Any questions why it's negative 1 and not positive 1? It would have been positive 1 if this was the problem. Now it would be positive 1. Now it's negative 1. Okay? So you just have to be careful with that. All right, so let's see what we do. Negative 1 cubed minus 2, what is it, negative 1 squared? Yep. put squared on that. Minus 1 minus 5. Okay. So let's see. Yeah. What's negative 1 cubed? Yeah.
Negative 1.
Negative 1. And then negative 1 squared is positive 1 times 2. So that's a minus 2. So negative 1 minus 2 minus 1 minus 5. So it's negative 3. Negative 3 minus 1 is negative 4. Minus 5 is negative 9. So again, g of x is not a factor of f of x. We haven't had any that come out with a remainder of 0 yet. We will not, but. Okay. So where that comes in really handy is if I asked you to do a problem like this. You should be able to get the remainder there in under 10 seconds, especially because you're just plugging a 1 in. If it was a number bigger than 1, raising it to the 47th power would be a little tough in your head. But a 1 shouldn't be. If you try to use long division to get the remainder here, look at all the zeros you have to fill in. You're missing everything from the 46th to the 13th term. You need to put zeros in for every one of those. And then you need to put zeros in for the x to the 11th, all the way down to the x term. So doing that with long division, that's going to be almost impossible during a test. But doing it with the remainder theorem, just plugging 1 in for x, super easy. 5 minus 8 plus 6, there's your remainder. Done. Okay. So any questions on the remainder theorem? So the last thing we're going to look at is the factor theorem. Basically, the factor theorem is just the remainder theorem coming out to 0. Okay? We've already kind of said this. So if you're going to divide by a polynomial, and again, it's got to be a simple one. So these theorems I'm showing you, they only work on the simple ones. But those are the only kind of problems we're going to do. We're not doing the more complicated ones. So if you divide by something that's x minus c. I'll give people a chance to copy that. Okay, so it says, let f of x be a polynomial, then x minus c will be a factor of what's in the numerator if and only if this number is a root. Well, how do we show that it's a root? That's equivalent to saying when you divide by it, you get a remainder of 0. Okay? All those statements are equivalent. If it's a factor, if x minus c is a factor, and in fact, I think I have it on the next page. Okay. You don't have to write it yet because we're going to come up to this. But if you have a number that's a 0, it means that number is a root. It means if you plug that number into the equation, you get 0 as the answer. It also means that x minus the root is a factor. So that's the important one. So in order to show that that is a factor, I'm going to show that the number after the minus sign is a 0 or is a root. Same thing. Okay. And the quick way to do that is use the remainder theorem. See if you get a remainder of 0. Okay, so let's use the factor theorem to show that x plus 2 is a factor of that. Okay, so if I want to use the factor theorem to show that x plus 2 is a factor, I'm going to do the division, and I'm going to hope that I get a remainder of what? 0. All I'm interested in is the remainder. So we don't even need to do the division. All we have to do is the remainder theorem and see if we get 0. That's exactly what this says. You're going to plug this number in, the number after the minus sign, and you're going to hope that you get 0 when you plug it in. That's the goal. Okay? So let's call, all right, so let's call the top f of x. Let's call the bottom h of x. What number do I have to plug into the top to get the remainder when I do that out? You gotta be careful. Yep? Negative 2. So if we plug negative 2 into the top and we get 0, then that proves what we divided by is a factor. That's the goal here. Okay, so let's see what we get. So negative 2 cubed plus 5 times negative 2 squared plus 5 times negative 2 minus 2. Okay, what's negative 2 cubed? Negative 8 plus negative 2 to the second power is 4 times 5 is 20. Positive 5 times negative 2 is negative 10 minus 2. What's negative 8 plus 20? Negative 12. And negative 12 minus 10 minus 2 gives me what?
0.
0. So what I just showed is that this number is a 0 of the numerator. What does that mean according to the remainder theorem? It means that x plus 2 is a factor. Right, so all these things we keep saying that are equivalent, I'm going to give you a list of them so you have them right now. Yeah, okay.
I was just going to say it's supposed to be positive.
Yes, you're right, thank you. 12 minus 10 minus 2 is 0. Yeah. I think someone said positive 12, I might have just put negative. Okay. So these are all different statements that are equivalent. If you've got a number that you plug into an equation and it gives you 0, then that number is called a 0. That number is called a root. And this is the important one. That's why I'm putting an asterisk. X minus that number. X minus the root is a factor. And visually, it also means that that number is an x-intercept. It's where it crosses the x-axis. Okay, so that fourth one's going to be very important for the last problem we do right now. Keep that fourth one in mind for the last problem. If I give you a number that's a root, x minus that number is a factor. That's what we just went through in the last problem. Okay, so in the last problem, I'm giving you 3 roots. I'm telling you what the roots are. I'm telling you I'm thinking of a polynomial, and the roots of it are negative 2, 1, and positive 3. I want you to tell me what the polynomial is. So if I typed it into my calculator and graphed it, it would cross the x-axis here, here, and here. Bless you. Since it has 3 roots, I know when I try to figure it out, my answer is going to have 3 factors. Let's start with the first one. I'm telling you that -2 is a root. If -2 is a root, what would be a factor? Yep.
X plus 2.
Yeah, now why did you say plus? I thought it was x minus.
Because it has to equal 0. So I would take the -2 for x and that is 0.
Yeah, so the idea is when you take this number and plug it in, you get 0. Well, if you plug in -2 right there, -2 plus 2 is 0. So that's perfect. How about, let's look at the next one. 1 is a root. What does that mean would be a factor? X minus 1. And what if 3 is a root? X minus 3. Okay, and we'll multiply those together, and that'll be our answer. And if you're saying, well, wait, if you plug 3 in other places, you don't get 0. You don't have to get 0 everywhere. If you multiply a bunch of stuff together, as long as you get 0 in one spot, the whole thing is 0. Bless you. So if you plug in 3 right here, that gives you 0 times 5 times, bless you, 0 times 5 times 2 is 0. All right, so as long as each one of those is 0 one time for one of those numbers. Okay, so let's FOIL it out and see what we get. Let's just start with the first two. X times x, what does that give me? So it gives me x squared, and then x times -1. So -1x plus 2x. So x and 2 times -1, -2. Okay, so that's what you get when you multiply the first two together. And now let's do the third one. X times x squared, x cubed, x times x, and x times -2. -2x, and now do the -3. Plus 6 will be the last one, yep. And -3 times x squared, -3x squared, and -3 times x. -3x. Okay, so we get x cubed, x squared minus 3x squared. It's a minus 2x squared. What's -2x minus 3x?
-5x.
-5x. And the only thing left is a plus 6. Here's your answer. Let's graph it and see if it crosses the x-axis where we said it should. So we got x cubed minus 2x squared minus 5x plus 6. And what are the three numbers we're looking for where it crosses? -1?
No,
-2.
Or -2?
1 and 3.
1 and 3, okay. -2, 1, 3. Perfect. That's exactly what we're looking for. -2, 1, 3. Yeah. That's it. Is there any questions on it? Yeah.
Could I just see the whole document?
The whole, yep.
Or like
Okay, so we're going to use that idea again on Thursday. We'll come back to what we just did again. Okay, so homework tonight, it's on page 171. And I just want to double check, because I might take off a question. Yeah, don't, actually, you know what? Don't worry about it. Yeah, no homework. That's the one I wanted to take off. So it's 1, 2, 4 through 6. I guess I could have just said 9 to 17 odd. Oh well. So, oh no, but I skipped 11, so never mind. 9, 13, 15, 17, 19, 20, and 32. Okay, so we'll take a look at that tomorrow. And then don't forget, I'll be after school on Thursday, so if you have anything you need help with or to make up, that's the day I'll be here.